This is the video lecture for Statistics Section 7.2, and what we're doing is we're actually going to be solving problems that require us to use the normal curve to find probabilities. So back in 7.1, we learned that if I have a normal distribution, then I have my normal curve, and if I could find the area of whatever section, then that's equivalent to finding the probability that that would happen. So first thing, let's remind ourselves that area is the same as probability. Okay, so I've pulled this up. This is from StatCrunch. So on every problem in this section, I would encourage you to use the StatCrunch and to just keep it open and just reuse it from one problem to the next. So I got there by doing stat calculators normal, because all these questions have normal distributions. So you want to look for that keyword in the question, because when you're taking a test, all the questions are scrambled, so you're not really sure what you're doing. Well, if it says the word normal, then that tells you that you're using a normal curve. And if they're wanting you to find the probability or find the z value or x value, then I would use the normal calculator from StatCrunch. So what I want to do is just talk a little bit about how to use this calculator and what it means, and then I will also have a StatCrunch video going through a couple of the questions so that you can watch. Okay, so you pull up your normal calculator, and this is what it looks like. And initially what they're going to do is, like on question 1, is they're going to give you some z-scores. And let's say they said, hold on one sec. Let's say they said, determine the area under the standard normal curve that lies to the left of z equals negative 1.59. So these numbers here are your z-scores. Z represents the number of standard deviations. So here I have 0 standard deviations from the mean. Here I have 1, 2, 3, negative 1, negative 2, negative 3. The mean is always the middle. So if I want to know the area under the standard normal curve that lies to the left of this, then first of all, let's think about what that would look like. So when z is negative 1.59, I'm going to be somewhere around here. So if I drew a line to the top and they want the area under the curve that's to the left of where z equals that, then that's really what they're asking for. Now, on your calculator on StatCrunch, this is going to be shaded in red. So how do I tell it that I want from negative 1.59? I put it right here, negative 1.59. This less than or equal to will make the shading on the left side. So if they want the area to the left of negative 1.59, I put that in, make this less than so that my red is on the left, and hit compute, which is right here, and my answer will be there, and that will give me the area. So let me plug that in on mine real quick, and I'll show you the answer that I get, and that way you can match it if you're practicing with yours. So negative 1.59, my area would be 0.0559, and that would be entered here. And of course you round it to whatever they say. I think they say 4 decimal places. Okay, so what went here was the z-score, and what was here was the area. All right, so all of question 1 is that way, right? You're just going to keep putting in new values for z and giving them whatever that output is. Question 2, the only difference is that they want the area that lies to the right. So they may have had the same z-score or not, but they want the right side shaded. So how do you make the red become on the right side, you would change the direction of this inequality. So this bounces the red left or right. And then you put your z-score in, you get your area out. Why do we get the area? Because the area is the same thing as the probability. So in this question, it would have, you know, like the question would have been, the probability of being more than 1.59 standard deviations to the left would be 0.0559. Okay, so why are we putting z-scores in there when this is called x? Well, here's the reason. If I'm using standard deviations as my units, so I'm 0 standard deviations away from the mean, 1, 2, 3, negative 1, 2, 3. These are called z-scores. And remember, in a previous section, we used the formula to convert from x-scores to z-scores and vice versa, right? X-scores actually had meaning. It'd be like, well, how many chocolate chips? Oh, maybe I have 1,000 chocolate chips as my mean, and I have 100 as my standard deviation. So this would be 1,100, 1,200, 1,300. Here I would subtract 100. This would be 900, 800, 700. Okay. So if I'm using numbers that actually have meaning, then those would be called my x-scores. If I'm only using numbers that refer to the number of standard deviations, then those would be my z-scores. But either way, you would put them in the same box. So z-score would go here, x-score would go here. So you have to read the problem and determine whether or not you're in z-scores or x-scores. But it's pretty easy because they'll say it's a z-score if it's a z-score, and if it's an x-score, they'll be referencing what the numbers mean, like chocolate chips, or you know, a woman's weight in pounds or something like that. Like the numbers will actually have meaning. Okay, so what should we know about this? If it's a z-score, then the mean, which is already inputted, is 0 and a standard deviation is 1, because we're using these numbers. So my mean is 0, my standard deviation is 1. Those by default are already input into the calculator, okay? But if they switch it to x-score, like in this case with the chocolate chips, then you must input the mean and standard deviation. So if my mean is 1,000, then I need to make this 1,000. My standard deviation is 100. I need to make that 100. So you will put those in if they're in x-scores, okay? And then you'll answer the question. So if you go through, question 2 is a z-score. So mean is 0, standard deviation is 1. Question 3 is a z-score. And now, instead of doing a left or a right, they want you to do something that's in between. So they're going to give you 2 z-scores, and they want you to find the area in between those 2 scores. So you're going to toggle this between, and it's going to give you 2 places to put your z-score. And the area that it gives you will be the area between the 2 scores that you put in. Question 4 is interesting. We're still in z-scores, so we're still going to have a mean of 0 and a standard deviation of 1. But now what they want is, instead of the area being in between, they want the areas to the left and the right of your 2 z-scores. So your calculator won't do that for you, but what you could do is keep it on between, get the area that's inside, and subtract that from 1, because the entire area, total area of under this curve, equals 1. And this is why this number, when they give you the area, is always going to be a decimal. It's going to be between 0 and 1, because probabilities are between 0 and 1. So if I want these 2 chunks, I'm going to find the between and then go 1 minus what I got from the between, and I will know the 2 areas in the tails. Okay, so let's talk about question 5. We're still working with z-score. Find the z-score that the area under the standard normal curve to the left is 0.52. So now they've changed the direction of the questioning. So instead of you telling them the area, they're telling you the area, and now you have to tell them what the z-score was. So let me clean this up a little bit. So all you're going to do is put your input in the other box. So if they tell you the area, so my area was 0.52, so I'm going to put 0.52 here. They want me to tell them this. They want also the shading to be on the left side, so I would change this so that my red shading is on the left side, and then I hit compute, and it's going to give me the appropriate value here. So in this case it was 0.05, and this, for these, they're typically going to have you round to 2 decimal places. So let me repeat that. So the first 4 questions, they were giving you z-scores that you plugged in, and then you were telling them the area. In question 6, they give you the area, and you tell them what z-score caused that amount of area to be shaded. So they're just flipping the question on you. Number 6, same thing, except they want you to shade to the right. Number 7, same thing, only they didn't refer to it as area. So this is where we want to expand what this means. So this is the probability, and they could say, what's the probability that such and such a z-score? They could say, what's the area? What else could they say? There are many things they could say that reference this box. It's early, sorry, probability. Okay, they could say percent. They could say percentile. They could say this thing called z sub alpha. I think there might be one more. We'll see as we go through. Okay, so on 7 it says find the z-scores that separate the middle 26% of the distribution from the area and the tails of the standard normal distribution. So if it's separating the middle 26%, then I want to do between so that I get a middle instead of just a left or right. And they tell me it's 26%. Well, the word percent implies I'm in the area box. Remember, this number always has to be between 0 and 1, so you can't put 26%. You'd have to do 0.26. And because we're in between, this is going to end up with 2 numbers, right? And in my case, it was negative 0.33 to 0.33. So, in other words, it was between basically about here and here. And they gave me the 0.26, which refers to the shaded spot, and I'm giving them the 2 z values that bounded that 26%. Okay, so question number 8 is where we have this little z sub alpha. So question number 8, it says find the value of z sub 0.47. We call this z sub alpha. And it's pretty easy as long as you just remember what to do with it. So z sub alpha, the red is always going to be shaded on the right. And the alpha goes in this box, which is why I put it in this column. So how would I find this? I would put 0.47 in here, and I would make this shaded to the right. And then I'd hit compute, and whatever this answer is, that would be my answer. So in my case, I ended up with 0.08. So this is just a shorthand way of asking the question of this alpha being the area, the amount that's shaded, and the shading for z sub alpha is always implied to be on the right side. So you want to make sure that you put that on the right side. The red needs to be on the right side. Okay, so same with question 9. That's a z sub alpha question. Red is on the right. Okay, then we get to question 10. All of a sudden in question 10, we're no longer using z-scores, we're using x-scores. How do I know it? Because they use x, and they give me a mean and standard deviation. So on question 10, they gave me a mean of 50 and a standard deviation of 7. So I'm going to put 50 in here, and I'm going to put a standard deviation of 7, and then I'm going to read the question. So the first part, they just want me to show them what the shading would look like if x was greater than 39. So greater than would be shaded on the right, and I would need a 39 marked here. So what happens is once I'm no longer in z-scores, so those aren't going to be 0, 1, 2, 3 anymore. They're going to be 50, and then if my standard deviation is 7, then this is going to be 57, 64, 71, right? 43 minus 7 is 36, and then 29. I think that's right. Anyways, and so you have to show them what that shading is and then find the probability. So if they're asking me for the probability that x is greater than 39, then this is gonna be greater. They only give you the option of greater than equal to or less than equal to. So if they say greater, just use the greater than equal to. And then I'm gonna put 39 in here, and I'm gonna hit compute, and I think my answer was 0.9420. Okay, so the rest of the questions are going to be using x scores, so you will need to input your mean and your standard deviation. So just to recap what we're doing, we're using the normal curve to find probabilities, right? The area that's shaded is the equivalent of finding the probability. They can use the word area to indicate the shading. They can use the word probability, percent, percentile. They could also use proportion. Okay, all of these imply this value in this bottom right box, okay? If it's a z-score, that's fine, you put it in here. These numbers will be 0, 1, 2, 3, -1, -2, -3. The mean will be 0, the standard deviation will be 1. If it's an x-score, then you need to put your mean and standard deviation in. These numbers will have meaning at that point. They'll mean something. But you still put your x-score or your z-score in this box, and this is where you get your area or your probability. One thing to remember about percentile, if they wanted me to find, let's say the 73rd percentile. Percentile is over in this side, right? So the 73 would go here, but remember, this box is the same as a probability. It has to be between 0 and 1. So that would have to be a 0.73 for percentile. Percentile is always shaded on the left because remember, percentile means you did better than 73% of the people before you, right? So that would be shaded left. So jot these down, remember these, and it'll help you keep everything organized and straight. And I'll do a StatCrunch video showing probably about a half a dozen problems. All right, bye.